This is problem number 6 from the Chapter 11 review packet. And we're trying to find the shaded area in the middle. And that shaded area is going to be the area of triangle ACE minus the area from sector A minus the area from sector C and minus the area from sector E. To find the area of triangle ACE, we're going to use the side angle side formula. 1/2 times 22 times 24 times the sine of 30. And that comes out to 264 units squared. And then in order to find any of these sectors, we need to know the radii for the different sectors. And in order to do that, we're going to have to do a little bit of work on solving triangle ACE. So we have angle A is 30 degrees, angle C we don't know, angle E we don't know, little a we don't know, little c is equal to 22, and little e is equal to 24. Because it's a side angle side case, the first thing we're going to do is use law of cosines to find little a. Once we know little a, we're going to use law of sines to find angle c, since angle c is not the largest angle. And we'll subtract those two angles from 180 to find angle E. So if that triangle is solved, about 12.06, angle C is about 65.8, and angle E is about 84.2 degrees. We have each of those stored into the calculator as the different variables. Next, we're going to try to find the radii of these different circles. And to do that, we're going to use the walk around. This value is A. So then, to find the radius of circle C, I'll just call that x for right now. Insert that temporary variable, and that means that this length is 24 minus x. And if this is x, that means that this length is alpha a minus x. So then this is also alpha a minus x. And then this length is going to be 22 minus the quantity alpha a minus x. These two segments must be equal to each other, so we're going to set those equal to each other. 24 minus x is equal to 22 minus alpha a plus x, because that minus negative sign will distribute. Add x to both sides, subtract 22, and add alpha a to both sides, so 2x is equal to this. X is going to be approximately 7.03, and we'll store this as x on the calculator. Now, using that value, we can plug that in for this 24 minus x to get the radius of circle A. We can plug it in down here for alpha a minus x to get the radius of circle E. So after we know the radius of circle C, we can plug that x value in for the expressions we had before. The radius of circle A is about 16.97, that's stored as y. The radius of circle E is about 5.03, that's stored for alpha z. So I have those labeled on the drawing now as well. Next, we need to start finding these different sectors. So the area of sector A is equal to the central angle, which is 30 degrees, so 30 over 360 times pi times the radius, which is y squared. We'll simplify down a little bit. 30 over 360 would be 3 over 36, or 1/12. Pi times alpha y squared. The area of sector C is equal to the central angle. Now we have that angle C already stored as C in our calculator, so it's C over 360 times pi times its radius of x squared. The area of sector E has a central angle of E, which we already have stored in the calculator, so it's E over 360 times pi times its radius of z squared. So then this value will go in up there, this value will go in up there, and we already had this value entered in right here. So now it's a matter of putting these into the calculator to evaluate. the area of triangle ACE should actually be 132. So the area that's shaded is 132 minus the area of sector A, which is down here, minus the area of sector C, which is down here, minus the area of sector E, which is down here. I have those approximate values in there, and when you store those in your calculator and you subtract each one of those, you get the approximate answer of 9.64 units squared.